Histograms is a graphical form of a frequency table. It's a data set that is partitioned into all possible categories and a number of data occurrences. Here goes an example of how many available cars in each household with a group of 50 households. Using this histograms, we look at the histograms with qualitative data. You first must determine if the data is discrete or continuous. Discrete, we count occurrences of each data value, but with continuous data, we must have to set up intervals and numbers called classes. For example, this is the first example of a histogram. On the left side, you set up the frequencies, and on the bottom, you put the number of cars, and then you set up and see the shape of the histogram. This is with discrete data. So, first, we're going to look at relative frequency distribution. It's the fraction of the total data observation that will fall within each category. Relative frequency equals frequency over sum of all frequencies. So you'll see on this chart, the first category has a number of cars, has a frequency, and then you see here with the red square that the relative frequency is the number of frequencies over the group or the sample that it's using. So for example, each group that has one car, there's eight houses have one car. 9 houses have 2 cars. 10 houses have 3 cars. 4 houses have 7 cars. 7 houses have 4 cars. 8 houses have 5 cars, and 8 houses have 6 cars. Next, we'll talk about cumulative frequency, which is the frequency at and below the current category class. It's another column of the table, which is shown here. How you're going to do that is you're going to take the first group, which is 8 out of 50, and then you're going to add it to the second one, and you get 17 over 50. Then from the second group, you add to the third group, and so on and so on. So the third group will be 27 over 50 because you're adding the second group to the third group to the fourth group to the fifth group, and then the sixth group, and then the fifth to the sixth group, and you get 50 out of 50, which equals 100%. Histograms for discrete data is a graph of the frequency table. You label the horizontal axis with the individual tables beginning in each class, height of each rectangle, and B, frequency or relative frequency. Discrete. Another thing for discrete, you draw each rectangle so they are centered over each discrete value or aligned to the left with the beginning of each class. They should touch. Width of each rectangle is the same. So you see here on this frequency that each rectangle are touching. The width is about the same. They're centered over each discrete value and assigned to the left, and they're touching. Here goes shapes of distributions. The first distribution is normal distribution. It increases max, decreases, and then it's symmetric. So you see it has a bell-shaped curve. This is called normal distribution. The second one is uniform distribution. It's evenly distributed and it looks like a rectangle. This one is skewed left. So you see how the little toes right here, a cute way to look at it is that the big toe is on the right. And the small ones are on the left. Same thing for this one. The big toe's on the left. And the little pinky toes are on the right. So this one's skewed right. There's a longer right tail. Okay, so here goes the frequency tables for continuous. So we're going to look at IQ scores. So you see how on the left side, there's the IQ score and the frequency. So we set them up in groups. The lower class limits are the ones that have circles. the smallest number that can actually belong to each classes. We create intervals called classes. Upper class limits are the side ones, where the largest number that can belong to different classes. And on the right side, you see the frequency, how many people scored that IQ in each group, each class. So you see here, the class width, the difference between two consecutive lower class limits are 20. So you see, you subtract from each one. 130 minus 110 is 20. 110 minus 90 is 20. 90 minus 70 is 20. 70 minus 50 is 20. So each class width is 20. Okay, so we're looking at midpoints. So you see how this group is 50 to 69, and the midpoint is about 59.5. How we get that number is we add the lower limit to the upper limit and divide it by 2 for each group. The class boundaries. So the class boundary is the halfway point between each classes. It's the upper plus the next lower divided by 2, which is about 0.5 difference of the first number in the class width. Okay, so this is how you position the class limits, the midpoints, and the boundaries. So you see in the blue is the boundaries. This right here are the numbers that for the class width. This is the midpoint. And then you see the boundaries. So these are the limits, these are the boundaries, and these are the midpoints. The boundaries are what's in each class. The limits are what's right about 0.5 before the beginning of each class. And the midpoints are basically the mean of each group, each width. So 50 plus 69 divided by 2, which is about the mean of each class. Okay, so the same thing with discrete. They do not overlap. You cover the range of data from minimum to maximum value, each same width. Open-ended classes. Okay, let's look at cell phone minutes. So, in this group, the minimum number of cell phone minutes used on a total of Monday through Friday is 67 minutes. The max is 125 minutes. So, for example, we set up the classes for a frequency table with the class starting at 67 with the class width of 12. So, if we find all the class limits first, start at a minimum of the data, add class width, lower plus class width equals next lower. Fill in upper class limits so classes don't overlap. So you see here again, these are the lower class limits. These are the upper. Each width of each class is 12. And then the frequency is distributed as an F. The summation of the frequency equals 30. So then, for another example, just like we've seen before, the relative frequency, you're just going to put the amount of frequencies over the amount of the sample. So 3 over 30 and then 5 over 30 because there's 5 in this category out of the 30. There's 8 in this category out of the 30. The commutative is fairly easy as well. So you're just going to take the first group, add it to the second group. So then we're just going to start off with the same as this one. Then you're going to add it to the second and get 8 over 30. The third group, you're going to add the 8 plus the 8 and get 16. The same thing with the next one. So you're just going to keep adding them. 16 plus 9 is 25. 25 plus 5 is 30. So then you get 30 out of 30, which also equals 100%. Okay, so then we look at this. This is going to be the histogram for that information. So then again, we see the lower class limits here. Then we see the boundaries here. These are the frequency of the colors that you've seen. You're going to label the horizontal axis with the lower class limits, the lower class boundaries, and the midpoints. And they're all shown here. This is all going to be the cell phone minutes. So you break the scale if you don't start at 0. So you see here, I broke this scale because the information starts on 67. And that's the little sign right here that you see. So, what shape is it? What shape do you think this is? You think it's a normal? Do you think it's a uniform? What about left, skewed right or skewed left? It's crazy because it's lightly left skewed. But you would think that it's normal. This is a summary of interpreting histograms. What is this info telling us? The objective is not to only construct a histogram, but to understand the data. So, number 1, distribution. Is it bell-shaped, uniform, skewed right, skewed left? 2, is it center? 3, variation. 4, outliers, sample values that lie very far away from the vast majority of other sample values. You label your class with boundaries, midpoints, horizontal, frequency, and vertical. Okay, lastly, just to freshen up your memory. 1, find minimum and maximum values. 2, make a chart with class widths equal, frequencies, relative and commutative. Then you find your class midpoints, boundaries, and lower class limits. Here's an example chart here. Label vertical axis, frequency F. Label horizontal axis, lower limits, midpoints, boundaries, and you'll see those all here. Draw your graph and touch each other. So these should always touch each other. Find the shape, i.e. normal, uniform, skewed left, skewed right, and then interpret the graph. What did you understand from this data? What can you guess about this information? Is it going up? Is it going down? Or just check the shape. And remember, if you don't start at 0, break the scale. The end.